Hello, Math Sci here. We're going to take a look at a problem regarding integration of powers, and there's trig functions involved in this problem. So what we see here are two integrals being added, and a lot of students, just by looking at this, are sometimes like, well, what do we do? I mean, yeah, you can break tangent, you can break either of these tangents into tangent squared, but which one do we go first? So that's the question, and that's how we're gonna have to, that's how we're gonna have to do this problem. Okay, so question is, what tangent are we going to break up? So, well, if we were to break up this one, it'll kind of just go into tangent squared times tangent squared, and it'll kind of get things messy, and it won't easily um it won't easily be solved correctly, and through the process it'll get messy, so that's something that we don't want. So what we rather do is split tangent 6x dx up like so. The integral from 0 to power 4 tangent 4x times tangent squared x dx plus the integral from 0 to pi over 4, the same as the original problem, tangent 4x dx. That's how we would set up that problem. Now, the next step is what's our next step? Well, this is where a lot of students get tricked up. Now, do we still have to break up tangent 4x? No. What you would do is you would simply get this integral and factor it out over here, like so. The integral from 0 to power over 4 tangent 4x times tangent squared x. No longer need to put the dx. Plus tangent 4x dx. Now, the next step is, you kind of already know that tangent 4x are common, so we would just factor that out. So from the integral is the integral from 0 to power of 4, tangent 4x as our factor, times tangent squared x plus 1 dx. That's how we would set that problem up. Now, this is where the knowledge kicks in. What would we use? What's the trig identity of tangent squared x plus 1? Well, you should know your trig identities, but I'll give you just a couple of them to kind of refresh your memory. So I'll just write trig identities. And what you would use is, what the first two, you know that sine squared x plus cosine squared x is equal to 1. And you know that secant squared x minus 1 is equal to tangent squared x. So that's what we know so far. That's what we know so far. So now, what trig identity would we use from these two right here to identify our identity over here? So we know that secant tangent squared x plus 1 is equal to secant squared x. So we'll write it as so. The integral from 0 to pi over 4 tangent 4x times secant squared x dx. So that's how we would simplify that. That's how we would identify that. And now what we would do is we're just going to make a line here. So now we know that the integral as 0 to pi over 4 is tangent 4x secant squared x dx. So now this is where the calculus kicks in. So we would say we would have to use u substitution. And question is, what would our u be? So the u would be our, we would have to pick our u, and we need to pick our u wisely because we need that u to be the derivative of itself in order to be dx. So the reason why we would choose u as tangent x is because oops, that's not dx. Is because the derivative of tangent x is secant squared x and dx. And it's pretty easy because you can just substitute that into your u. So, and also change your limits of integration. So, as x equals pi over 4 and x equals 0, for pi, as u equals tangent pi over 4, that equals 1. U equals 1. And as tangent is 0, u is 0. That's how you would change your limits of integration. So now, from that, you would just do this. Now just plug in u into your equation, into your integration. So now you know that u to the 4th, because since tangent equals u, is dx. Now, this is where the calculus also kicks in. So now what we do is antiderive, integrate u to the 4th. So now, you do this. U to the 4 plus 1 over 4 plus 1. That's how you would integrate. And also don't forget to put your 0, your limits. And from there, that equals u to the 5th over 5. So now, what we do is we use the fundamental theorem of calculus, and that would be 1 over 5 minus 1 to the 5th over 5, or actually it's 0. So 0 like that. That's how you would use the fundamental theorem of calculus. So now you know that 0 to the 5th over 5 is really 0. So now the answer to this problem would be 1/5. That's how you would solve this problem. At first, it's very complicated. It's very tricky. How would you integrate two integrations and add them? But the real problem is just knowing how to break them up on one integration and then substitute that for the other. And that's how you would simplify this problem, and using powers of integration with two integrations added together. I hope this helps, and Matt Tsai here. Hope you have a wonderful day.